Okay, gang, let's do number 45. So I found the derivative. If you want to see how I did that, it's first piece, product rule, right? So first times derivative of the second piece plus the second piece times the derivative of the first piece. And then I factored out the common factor, e to the x minus 3. And in the front half, I was left with the 3 minus 1. In the back half, I was left with the minus 1. When I combined like terms, I got that. Okay, so now when you set this equal to 0, this piece will never equal to 0. Like, you guys know what this looks like from pre-calc. This is e to the x looks like that, right? Let me try to find a little spot where I have more room to say what that looks like. E to the x looks like that. That's better. And then this is just shifted 3 units to the right. So e to the x minus 3 is the same graph. It's just pushed 3 units over than the original. So basically what I'm saying is this will never equal to 0. At the x-axis, it actually has a horizontal asymptote. Both of them do, this one and this one. So it never touches 0. So in terms of the critical number, this part will never equal 0, but this part will. This part will equal 0 when x is 2. So that's the only critical number you have for number 45. So as you know, you put that on the number line. And I should say that the domain of this function is all real numbers, right? Because if you have any restrictions, you have to take note of that. All right, so we can test the whole number line. The original graph of f is on the whole number line, but when we look at the derivative, we're going to put down the critical number of 2. So then I picked test values of 0 and 3. By the way, just as we sort of discussed here, this piece right here is always going to be positive. I drew it for you, right? This is always above the x-axis. It's always positive. So you don't ever have to plug anything into here. This piece will always be positive. So the only thing you have to worry about is this piece. Okay, so when I plug in 0 for this piece, I get a positive times a positive, which overall is positive. Right, so that's why I said this here. And for this one, when I plug in 3, the first part is always positive. When I plug 3 into here, it's negative. So a positive times a negative is negative, which is why I got this. So the function's going down, the derivative's decreasing. Okay, so for part A, you should have the critical number x equals 2. For part B, you should have that the function is increasing from here to here. So that's negative infinity to 2, decreasing from 2 to infinity. Right, that was part then B. Then part C is to do the first derivative test. So around the critical number, the function goes up and then it goes down, and that creates a maximum. So the pattern of the derivatives of it going up and then down creates a maximum. So we can then say it's a max at 2. And then don't forget, you have to go all the way back with that 2. You have to go back and you have to plug it into the original function. You have to plug it into the original function to solve for the y value, because later on, as you learned in 4.6, you're going to graph this stuff, okay? So this is the xy coordinate where the maximum occurs on the original. All right, gang, that's it for 45. Hope that helped.